Okay, one and all, welcome, welcome. It is the moment you've been waiting for. It is day 3 of Advent of Code 2020. All right, so let's take a look at what is today's problem. What do we got? So, with the toboggan login problems solved. I bet that was on purpose. Toboggan login. I just caught that. All right. Appreciate it. With the toboggan login problem solved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to local geology, trees in this area, only grow on exact integer coordinates in a grid. You make a map, your puzzle input, of the open squares, signified by periods, and trees, signified by hashtags, that you see. For example, okay? Pretty straightforward so far. So these aren't the only trees, though, due to something you read about once involving arboreal genetics and biome stability. Some good reading you've been doing. The same pattern repeats to the right many times. All right, so this is basically saying we're only going to give you this much, but that exact pattern is just repeating. So if you need to go farther to the right than what the input has provided, you just repeat the input that you already got. Okay? Got it. So you start on the open square in the top left corner, that's up here, and you need to reach the bottom. So that's below the bottommost row on your map. So let's assume you have to travel through all of the rows on your map. The toboggan can only follow a few specific slopes, apparently because you opted for a cheaper model. So you start by counting all the trees you would encounter for the slope right 3, down 1. Okay. So from your starting position at the top left, check the position that is right 3 and down 1. And then right 3 and down 1, right 3, down 1, right 3, down 1. Got it. Okay. So the locations you check in the above example are marked here with an O, where there's an open square, and with an X, where there's a tree. All right. Makes sense so far. So basically, we're going to be going right 3, down 1, right 3, down 1. And we're going to count every time that we land on a tree as we're going down this path. Okay, so given that slope, you're going to hit 7 trees. So basically, starting at the top left corner, following that slope, right 3, down 1, how many trees would you encounter? Okay. Cool. So this is the moment that I've been waiting for. There's always a grid problem in Advent of Code. Sometimes, quite often, it's the very first day. But today, they made us wait till the 3rd day. So it has arrived. Here we go. Here's our puzzle input. Okay. So let's just do sort of the standard thing that we do every time. Let's open up our editor. Let's go to puzzles. Create a new folder. For day 3. Awesome. Part 1, markdown. Let's copy and paste this entire thing in there. Okay, nice. Now we can say this is context. Context. And then this is where the examples start. So this one's a little bit different because it's not quite... Let's see. Just going to leave that there. Just thinking of how to organize this. It doesn't matter that much. So this is the question. Okay. But for the purposes of our test, which today let's write the test first for this one. Okay. All right. So we have a problem there. Cool. Let's just grab our input really quick. Save that in a text file. That's this guy right here. Boom. Okay. Input saved. Great. Cool. So let's go Ruby. Day 3. And we're going to start with the test. do a little TDD. So what does day 2 test look like? I'm just going to be lazy and kind of copy all this stuff over here. Awesome. This is going to be requiring day 3. Doesn't exist yet. What should we call our class for day 3? Maybe we'll call it, I'm not sure, toboggan map. How do you spell toboggan? I've read the word so many times, and toboggan. Okay. Toboggan. Toboggan map. Do. Okay. So we're gonna, and you know what? We can start kind of as we're doing this. Let's start a new file for day 3.rb. Okay. There's our new file, and then let's just say toboggan map. Great. Okay. And so what are we doing? We're counting trees. So let's call this count trees. And now our input here, and so we'll just say count trees, and then we'll just return 0 right now. Let's say we're going to initialize this with some input, and for now we're not going to do anything with that. This is just kind of a placeholder for when we eventually do things. So that's going to be that. So now I'm going to pop back into our puzzle and grab this example. Okay, so there's our example of the different lines of input that we might have. Let's just make that indentation look really nice. Oh. Bum, bum, bum. Okay, great. So there's our input, right? And it's saying that for this input, the number of trees that we're counting should be 7. Okay, so let's go down here. Let's get rid of all that stuff. And it goes, it counts the number of trees encountered. There we go, we can spell. We know how to spell. Okay. So how are we going to call this? So let's just assume that we're going to say map is toboggan map new. We'll give it our input. And then we'll call map that count trees. So now one thing that I'm thinking here, so there's a lot of different ways that we might traverse this map, but in this specific case, we're going with the slope right 3, down 1. So maybe we'll, excuse me, maybe we'll pass that as an argument to count trees of what is our slope. All right, so maybe we'll say, let's just give it the kind of down 1. We'll do something like this where we have some keywords, or maybe that's a hash or something that has our slope in it. And we're saying, all right, right 3, down 1. Okay, we want to count all the trees on this slope. Cool, cool, cool. Okay, so that looks pretty good. But what should this be? So this should be 7. So that's an important part of tests, is actually expecting something. So we expect that to equal 7. Okay. Awesome. So now let's start implementing that, because basically if we go and let's just see how everything is doing here. So let's go into Ruby. We're going to do rspec day 3 spec.rb. Okay, great. So wrong number of arguments. Okay, so our little count trees. So we didn't, we didn't say that this takes any arguments. So you know what? For now, let's just assume that those are the only types of things you need for a slope. Let's just say right and down are keyword arguments that you need to have. And so I think that that is a valid thing that you can do. Okay, so it's just saying, oh, interesting. Well, you know what? I'm just going to start defining this. So, okay, cool. Count trees takes writing down. So the first thing we're going to do is we're going to store these arguments in our slope. And our slope is right, and down is down. Okay. Cool, cool, cool. And so now, let's see. Actually, let's take a pause on this. What we need to do first is to parse our inputs. Right, so how are we going to parse this input? So let's go take a look at that one more time in the test here. Okay, so we've got a coordinate system that we're going to build here, and for each coordinate in our grid, we're going to have, it's either going to be open or there's going to be a tree on it. All right, so keeping a coordinate system, pretty straightforward. We're just going to do an array of arrays where each row is one of these lines, right? And then maybe we'll have, let's actually make a new class to store what's at a given coordinate, right? And let's say that, you know what, we don't even need to do that. I'm just thinking about what would that class even store? It's going to store whether or not it's a tree. But we can accomplish that with just a simple Boolean value. So we don't need to worry about having a whole class to sort of define that. We can just use Booleans, right? Because that's the only thing that it's going to return. So let's start defining this. We're going to have parse input, as always, is our tried and true method name that we're going to use here for parsing input. And let's start defining that. So parse input is taking a string, which is our input. All right, so the first thing, as always, breaking this down into multiple lines. So string split on line breaks, okay? So then the next thing you want to do is we're going to map over this, and we have individual lines, right? All right, cool. Let's break this out like this. Okay. So now what do we want to do with our lines? With our lines, I think what I'm going to do is I'm going to map over each character in the line. And if there isn't a tree, I'm going to store false. If there is a tree, I'm going to store true. And that's going to help me count how many trees I encounter. So let's see. So we can do line, and this should just be line. It doesn't really matter, but I like keeping it consistent. So it's just one line. We're going to call it line. All right, so we're going through the line. So line, map, and then we're going to have a single character. So if that character is a period, then what we're going to return is false, not a tree. Otherwise, we're going to do true. So we know that there's only two possibilities for characters in our input. So that should do it. Okay, so there we go. What this should give us is a big ol' array of true false values. Okay, so let's see, what are we going to do in order to count how many trees we go through? So this is going to look something like, we're going to go through all of these different lines. Let's call this something other than input now. So let's call this rows, I guess. Or we can call it the map. I don't know. Rows feels a little bit better. Let's give this an attribute reader, rows. Awesome. Okay, so basically, let's think this through for a second. So we're going to keep on going along this slope until we reach the bottom. And as we're going, we're counting how many trees we land on. So it's something like until, let's do current row, and we start at 0. And then we can say something like current column is also 0, right? And then so we say until, we're probably going to do something like until current row is greater than the number of rows in our input. So we can just say rows dot count, except if current row is going to be our index, it's actually going to be one less than the total number of items. So until the current row is greater than the number of rows minus 1, we're going to follow the slope and count our trees. And here we go. Up here we'll put trees. We'll just say equals 0 to start. And then at the end, we're going to return our trees, right? So let's see. So it's possible, it doesn't happen in our examples, but let's assume that it's possible that the first row is itself a tree. So how would we handle looking at the first row? So what we're going to do is, first thing in our loop here is we're going to check where we currently are. We're going to add to trees if it's a tree, and then we're going to change the current row and current column values using that slope. So let's say current coordinate is, that would be rows at current row, and then current col. And let's say trees plus gets 1 if what is ever in this place, rows at the current row and the current column, is true. And so we could just do like this, because if it is not a tree, this is going to be a false value. If it is a tree, it's going to be a true value. So that's it for checking what's there. So now the next part is we need to advance via this slope. So what does that look like? So down is adding 1 to our rows, right? Because we're looking at an array of arrays where 0 is the beginning and then 1 is the next one and 2. So even though we're moving down on our map, we're moving up in terms of the row number. So we could say current col plus gets whatever this down value was here. And you know what? I had stored this in some sort of object, but that's not necessary. Okay. Okay. And now if we look at the row is also going up. So because in an array, left would be going down and right is going up. So current row is whatever the current row is plus right. Okay. So that should work as long as we never move outside of the bounds that we've defined. However, we know we're going to, because we've seen it in the example and they already gave us rules for how to handle that case of, wait a minute, what happens if I move so right that I'm actually outside of the, the input that you gave me. And so what they said is that the same pattern repeats, right? So if we were to just grab this bit and paste it on the end there, right? So that is what it looks like there. And then this one, right? So that's what that one looks like there. The pattern repeats. So how can we handle that in code? Well, there's 2 different ways that immediately come to mind. The first way that comes to mind is, okay, so if I know how many total rows I have, I know that each time I go a row, I'm going to the right 3 places. I could use that information to figure out what is the farthest right that I will ever go. And then I could make sure that every time that I build a row, I build out, I copy this pattern all the way out so that I actually have that information. Another thing that I could do is, knowing that this just repeats, I can actually only store the interesting part, which is this sort of uniqueness. All right, I don't need to store it repeating. What I can do instead is, once I've moved too far off of this, I know that is equivalent to looping back around at the beginning, right? So it's not equivalent in terms of like, oh, what's my actual coordinate? Like if I was looking at this on a map, right? It's not the same, whatever, I don't know how many this is, but let's just say it's 10. So like 11, in terms of whether or not there's a tree or not, 11 is the same as 0. It's, you know, right? That's all that we care about. We're not trying to figure out like how far have you traveled, in which case like we actually want to know what coordinate you are on this grid. Now, I'm going to make a quick prediction here. How far have you traveled is going to be part 2. We'll see if I'm right about that. But if that's the case, then we'll refactor this code as needed. But for now, I don't care what the actual coordinate is. I only care, is there a tree there or not? So that's all. What I can do here is I can just kind of loop back around to the beginning every time that I travel outside of it and keep doing that. And so how can I do that in terms of code? So the way that you can do this, and I'm going to pop open a new tab here real quick so that we can explore this in the Ruby console here. So let's say I have something that is an array that has 4 items in it, right? 1, 2, 3, 4. And this is our array, right? So at 0 is 1, right? So if we said 0, 1, 2, 3, 4. So at index 4, let's just kind of do it like this, right? It's nothing because we've gone off the edge. How can I get that to wrap back around? Is what I can do is array at whatever the index I'm trying to get modulo the size of that array. So in this case, it's 4. Okay? So I've looped back around to the beginning because what is 4 modulo? 4 is 0, right? So, and just real quick, if you're not familiar with the modulo operator, you never heard of modulos before, what a modulo is it's the remainder after doing integer division, right? So 4 divided by 4 is 1, remainder 0, and that's why 4 modulo 4 is 0, okay? What about if I did 0 modulo 4, okay? It goes in 0 times, it has 0 remainder. Perfect, that works there. What if I do 1 modulo 4? 1 goes into 4 0 times, it has remainder 1. And so what this allows us to do is basically we can continue to increment the column that we're on and then modulo 4 that, and it's just going to loop around between the numbers 0 and 3. Right, and so we can actually see this happen. So if I do, let's say 1 to 10 each, I'm going to have a number, and I'm going to print number modulo 4. Right, let's see what this does. 1, okay. Oh, because I started at 1. 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, right? So that would repeat. So now we have a way to stay within the bounds, right? And so we're going to use that here. So this is going to be current row equals current row plus right modulo current row dot count, right? So we're, however big it is, that's what our modulus is, okay? We're not doing the same thing for down because once we hit the bottom, we don't want to loop back around to the top. That's it. That's the end of the game, okay? Okay, so this should do the trick. I think that is all there is to it, which feels kind of surprising, but let's run tests and let's find out. So we're going to go to admin of code, Ruby, rspec day 3. What is it? Oh, I've been spelling it out. spec.rb. Okay, failure. Undefined method map for a string. Okay, so what's happening? Let's see. So here is where it's telling us that we don't know how to map. Okay, and let's actually look at something here. Oh, we've got a bunch of empty spaces in there. So one thing that I'm going to do is, I believe, and let's just use a console here. So if I have a bunch of space and then I have stuff, and then I use this method strip. Awesome. So that's going to get rid of our extra white space for us. We're going to do that. But now I want to be able to map over these as characters. So I had assumed that if you call map on a string, it would just treat it as an array of characters. Not the case. So in that, it's got a simple solution here, which is we're just going to split on nothing. When you split on the empty string, that means split into individual characters. All right, so let's get out of here. Run this again. Oh, undefined method count for integer. Okay, so I don't want to count what the current row is, right? What I want to do is count the number of rows that I have. So that was a little variable mishap there. All right, let's see if this works. It's taking a really long time, which makes me think we don't have that many lines of input here. So something's happening. Row. What's happening? Here we go. So this is me confusing rows and columns. So I said specifically we don't want to do this for rows, and then I did that. So actually this should just be row. Current row plus gets down. Current column is current column, and then it's not rows dot count, but we can simply look at how long is the first row, right? And you know what? We don't need to actually do that in every single loop. Let's just kind of store that immediately. So we could say column width is rows dot first dot count. Okay, and then we can do another col width here, and then I can change this right over here to column width. Okay, so let's run this again. There we go. Finished nice and speedy. Okay, cool. So once I got myself straightened out here, this seems to be pretty straightforward. And so now let's actually try this on the real input. So how can we do this? So I'm going to go into one of our solution files, copy this, create a new one, day3 solution.rb. All right, put that in there, and we're getting from day 3. Again, the input is also from day 3. We can get rid of this. We only have part 1. I already forgot what I called the class. Toboggan map. Okay, toboggan map, new input, and here we're doing count trees. And what is our arguments? Our right, RIGHT 3 down 1. Awesome. Okay, that looks pretty good. Let's run it. Ruby day 3 solution. Oops. Solution. Run it. 250. Okay. Let's put it in. Cross our fingers. What do we got? 250 is the right answer. Amazing. Okay, part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop, after all. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. All right, so right away, let's just, my prediction that I made a few minutes ago about what part 2 is going to be, totally wrong. All right, so that's a good thing that I didn't optimize my solution for that incorrect guess at what future requirements would be, which is a good lesson that only build to your current requirements, right? Don't build for the future that you think might happen, because if I'd done that, I would have been wrong. So instead what this is saying is follow all these slopes. Okay, so follow all the slopes. and then multiply them together. Okay. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Okay, so this actually looks like this should be a very, very easy one to solve. So let's see. So what we're going to do, we can actually keep toboggan map. And let's see, let's do product of slopes. And then we're going to be given some collection of slopes here. And what we can do is we're going to do slopes.map. Here's a slope. We're going to call count trees. And actually, so what we can do here is we're multiplying them all together. So we can do reduce. There's our accumulator. We want to count trees for, let's just say that our slope is going to be, each slope will be a hash that has the keys right and down. So let's do this. Right, GHT, S right, down is S down. Okay, and then we want to multiply that times the accumulator, which is going to have all the trees. And that, I think that's actually everything. All right, that's literally it. Let's see, day 3 spec. It calculates the product of many slopes. Okay, so map is toboggan map. New input, right? Because there's one map, and then we're doing many slopes on it. And let's say, let's do a new let here, and we'll say slopes. What is slopes? So that's an array. Each item in the array is going to be a hash. And here we go. So these are all the slopes that we care about. So let's just kind of paste that in here, and then we'll kind of clean up this formatting. So this first one, right 1, down 1. Okay. Formatting stuff is fun. Right 3, down 1. That's the one we already did. Good to know. Put a little curly bracket around that. Awesome. All right. Right 5, down 1. Awesome. Bring this back right there. That's good. Oops. Hitting all the wrong keys. Okay. Oh, definitely not what I wanted to do. There we go. All right, and then we got one more. Okay. Right 1, down 2. I think that is everything there. Okay, so those are all of our slopes. So we're going to say map expect map dot product of slopes, and then we will use the slopes that we just defined to equal. What do we expect it to equal? Let's take a look at that. 336. 336. Okay. I think that's it. Let's run our test. Day 3 spec. Oh, okay. So what's happening here? Product of slope, no implicit conversion of symbol in integer. Cool. So that usually means that I'm trying to access an array as if it's a hash. And this is happening on line 10 of day 3.rb. So what is on line 10? Everything is on line 10. Okay. So slopes.reduce, slope, accumulator, count trees is S at right down. So interesting. You know what? I'm just going to require pry. And I'm just going to throw in a binding.pry, not there, but instead I'm going to do it inside of this reduce. So just kind of make this a little bit easier to work with. All right, binding.pry, awesome. So now I can run this again, and we got a debugger in there, so we can see what's what. S is 1 and ACC, okay. Classic error here, switching up the order that arguments from reduce come in. Accumulator is the first argument. All right. So now that we got that fixed, let's get rid of our debugger statements. Let's get out of here. Let's run that again. Awesome. 2 examples, no failures. So now, that was almost too easy. Let's go in, sorry, day 3 solution. We're going to put part 2 to count. And so what is this called? Let's go down into our test again. King of forgetting the methods that I just defined. So product of slopes. Cool. And so I'm just going to also kind of steal these. Slopes is that. Let's kind of make this nice. Okay. That's looking good. Change this to slopes. Okay. Let's see. Moment of truth. Oh, wow. Look at that one. That's a big number. Okay, I'm going to copy that. Throw that in here. Submit. Boom. Okay, day 3 in the books. Wow, record time, 37 minutes. That didn't take very long. Okay, cool. Well, in that case, we get the gift of more time to ourselves. Looking forward to day 4 coming up next. Thanks for joining us, and we will see you soon. Have a good night.